Okay. So once again, good morning to everyone. Today we are going to start our second unit. The second unit is nothing but highway geometric design. In the first unit, we have briefly covered the need and why we want to do this, study this particular subject. So all the things we might be learned in our first unit. Also, very briefly, we have a seen in the first unit what is the need and what are the factors are influencing to design the various geometric characteristics that we have covered very broadly. So this is with respect to the first unit. In the second unit, I told that we are going to cover a little bit micro level, all the parameters, how it is designed, and what are the considerations we are considering as a factor that we are going to cover in the four main chapters. So first, initially, we will see what are the factors that are affecting the geometric design. Then specifically, we can try to design the side distance. So I will explain deep in micro level once the specific topic comes. Again, it will be repetitive. So here the side distance, how we are stopping to avoid the collisions, how we are taking the overtaking, and how the side distance visibilities are existing or considering at the intersections. All these three major components you are going to study under the side distance. Then the third one will be the various elements like a horizontal alignment and the vertical alignment. These two major component we are going to cover with respect to the problems as well as the some of the derivations theory. Under the horizontal curve, it having the super elevations, extra widening of the pavement and the transition curve. Other than that, in the vertical alignment, gradient and the summit and the valley curve, two types are there. So all this curve, how the factors are influencing, what are the parameters you are considering and what kind of the definitions we are giving and some of the example problems we are going to cover throughout this particular unit. So mostly this is also one of the important unit where you understand the various design element and the factors influencing how to design and what are the IRC recommendations are there and how the calculations are happening and different kind of the problems we are going to see in this particular unit which have the high scope for your competitive exam. So definitely when it is coming to that UPSS the gate exam and all, there is a high probability to ask the questions from this particular unit, specifically from the stopping side distance estimations or the overtaking side distance estimations or the super elevations, okay, or maybe the gradients related to design in the vertical alignment. So these are the four major chapters where we can expect the confirm the questions in your competitive exam. So this is an overview about that exams oriented, as well as even though if you are not focusing for that exams as a civil engineer, you must know how that designs are existing. Even though you are focusing on the structural and the other elements, when it is coming to the bridge constructions or road constructions and all, so it will be generalized one where you can learn or understand all these factors. So this is the main motivations and objective of this particular unit, and these are the content you are going to cover in this particular unit. So let's start with the first chapter or the first sub class sections, we can say factors affecting geometric design. So already we have seen the geometric design, what we are doing in the sense the road, it might be the new road or the existing road. In case if you want to propose between the A to B, the road supposed to be straight or it might be curved one or it might be the vertical curve. So different kind of the components are playing the major role with respect to the existing terrain type. It might be the plain terrain, okay, or it might be the rolling terrain, it might be the mountain or the steep terrain. So with respect to the angle, so we are explaining the terrain how it is existing. So considering those terrain type and the considering the various factors, last unit we have seen the center line we are trying to mark it, and according to that the both side we are widening or we are constructing the road. So accordingly, we are executing how the final structures will be there. With respect to the center line, the alignments are happening. So based on that, so we are defining how the things are existing. So the geometric design of highway, it particularly deals with the dimensions and the layout of the visible features of the highway. So that alignment or the dimension is nothing, visible features or the dimensions is nothing but alignment, side distance, and the various facilities like a signalized intersections or the unsignalized intersection. So this is the things, and these are the basic requirement. Whatever the alignment you are proposing, whether it is a straight road or the horizontal and all, it's supposed to be short and straight as possible. The alignment should have the minimum cutting and embankment. Okay, else it is require the more work manpower, as well as the materials is refilling is required, and the design you have to change it accordingly. So those kind of that things is changing when it is coming to that ideal alignment. Then it has an easy gradient and smooth curve, then deviate from the marshy land and poor soil area and the ponds. So those kind of that obstacles also we need to consider to eliminate those things, okay, when you are planning for the new highway or the road alignment structure. And it's supposed to be on a high level ground for the natural drainage. Then the minimum number of cross drainage work supposed to be provided. That's supposed to be not in the more number, as much as we can able to eliminate the crossings. So that will make a different kind of that advantages when it is coming to the road alignment. Also the material supposed to be get nearer material, so that which ultimately reduce the transportation charge. So with respect to the available materials, so we try to propose or the constructor that particular alignment to avoid the transportations. Okay, then it's supposed to not pass the forest, okay, built up areas, religions places. So those obligatory functions are we need to eliminate when it is coming to the proper alignment. And the crossing, when it is coming to the crossing, we need to provide the right angles, and we should avoid the zigzag curve or the S type of the curves, which provide the discomfort for the drivers. Sometimes there is a high possibility of skidding or the sleeping from the road structures. So those uh, accidents possibilities happen when it is coming to the things. Then it's supposed to be economical. It has to cover all the rural village or the town whatever it is passing through that particular A to B, and we need to consider all the obligatory points, and it's supposed to be look as an aesthetic sense. So these are the basic requirements or some of the key points which we need to keep in conditions while you are designing an alignment, which ultimately replicate that ideal alignment of that particular road structure. So with the basic requirement, we just move to that objective. So the main objective of geometry highway design is to provide the optimum efficiency in traffic operations with maximum safety, and it's supposed to be in the economical way, which is nothing but the reasonable cost. So these three should be achieved when you are proposing the proper geometric highway design. So this is the main objective. Example, if you want to propose some highway with respect to the various geometric characteristics, then the traffic operation should attain that optimum efficiency level while operating that particular highway. It should provide that maximum safety for the driver as well as the passenger. Finally, it should be economical with respect to the constructions company or the government, as well as road users, which is nothing but us. So who are using that particular road infrastructure. So they also should economical benefit. When we are trying to achieve these three major objective, so that is considering as a main objective of geometric highway design. So as I mentioned that these are the 5 elements which is mainly considering in this particular highway design, like the cross section element, stopping side distance, horizontal alignment, vertical alignment, and intersections elements. So all these elements, how we are designing, that we are going to study in micro level in this particular unit. I mentioned that the first chapter is nothing but what are the factors affecting the highway geometric design. So those design controls and criteria are, as I mentioned, the topographic. What is that existing topographic of that particular locations? Design speed of that vehicle in that particular corridor, road uses characteristics. So definitely it is varies with respect to the state to state. Example, in India itself, the road users behavior changing for the Tamil Nadu with respect to that what we can say Mumbai or the Delhi or the Karnataka, Andhra, or even it is varies with respect to the country as well as the country to country. US road users characteristic is differ, engine characteristics differ China. So we can segregate and we can identify the variations on the road users characteristics. The vehicle characteristics, yes, it is also influencing. Two wheeler is different, auto rickshaw is different, right? And commercial vehicle is different, buses are different. So the vehicle characteristics also influencing. Then the traffic, the volume of the traffic, high volume, low volume, whether it will be the one way or the two way, the u-turn is prohibited or the u-turn is allowed, right turning, left turning. So all the directional distributions, speed of the vehicle, so parking, so all the traffic related parameters are controlling the what we can say the alignment elements. So the this particular chapters or the factors we are going to study micro level in your third unit. Then the environmental conditions, it might be the weather, the rainy or the non-rainy, sunny. So definitely the environmental is affect. Then the economy, how the constructions cost, economical maintenance, how the operation is going to affect it. So all these factors are seven major factors are controlling the design criteria design, as well as it is making the criteria to fix what will be the minimum super elevations or the maximum super elevations, what is the curve radius for that horizontal curve. So all the criteria can be finalized by considering all these seven factors. So those factors only I have explained in the further slides. Example, the slope, plain terrain, rolling terrain, mountain terrain, steep terrain. So these topographical characteristics, design, speed of the vehicle, volume. So all the things are affecting the design criteria. So other than that, the aesthetic purpose, landscaping, air pollution, how it is, the noise pollution. So all these factors also considering under the environmental factors. So this is in a one sectors we are considering. In parallelly, the payment also one of the major factors to influencing or the controlling factors when it is coming to the design. Okay, so the payment surface depending upon the payment type. So it might be that flexible payment or the rigid payment that can be finalized based on the availability of the material, volume and compositions of the traffic, how the soils upgrades are existing, climatic conditions, construction facilities, and cost consideration. So all these things are considering and deciding how we are finalizing the surface characteristics of the payment. Okay, and the surface characteristics are very important because it is influencing with respect to the frictions, payment unevenness, light reflecting characteristics during the night time or the foggy time or the rainy time, then the drainage of the water surface. So when we are not providing all these things properly, then there is a high possibilities of skidding or the slipping of the vehicle. So when we are trying to negotiate that horizontal curve, there is an unevenness observed on the surface, then there is a chance the vehicle get out of control while turning this particular horizontal curve, probably 100 km per hour. Then it skid from the road or it may skid or the roll or the slip from that particular horizontal curve. So this is the things are considering as a major effect when we are not providing the proper frictions. So this frictions or the skid resistance, what are the factors if it is affecting in the sense the type of the payment, roughness, conditions of the payment, whether it might be wet or dry, tire conditions, speed of the vehicle, how the braking efficiency are there, the load and tire pressure, the temperature of the tire and the payment. So all these things need to be considered or the factors which affecting the frictions or the skid resistance when the vehicle is traveling on that particular horizontal curve. So basically it is happening between the tires and the pavement. We can say the hydroplaning. Okay, so when it is coming to the water, the droplets, how it is happening between the gap between the tire which is designed. So definitely, what we can say, when it is coming to the dry pavement and all, already smooth and worn tires will be there. That is giving the higher frictions. But when it is coming to the wet pavement and all, so the new tire is giving the higher frictions. So it is varies with respect to the payment conditions as well as that lifespan of or the life period of that particular tire. So with respect to the various research and the practical feasibility, also the Indian conditions, the IRC, Indian Road Congresses recommended the coefficients of the frictions. So whenever the problems we are going to solve in this particular unit, so when we are talking about that longitudinal coefficients of the frictions, so that value is considering as a 0.35 and it may vary still 0.4, but standard we can consider as a 0.35 for the calculations purpose. At the same time, when lateral as well as the longitudinal will be there, so this will be the longitudinal, the IRC is recommended. When it is coming to the lateral, so the coefficient it is considering as a 0.15. so this is the frictions value, we can say F. So this is a notations which we used to refer as a coefficients of friction. 0.35 for the longitudinal directions and lateral friction 0.15. So there is a chance of asking the questions related to these coefficients of frictions. Keep the value in your mind. So that is the things with respect to the frictions we are considering. Then the payment unevenness are happening. Definitely it is affecting the cost, comfort, fuel consumptions and the wearing tearing properties of the tire as well as the vehicle. Then the pump integrator we are using, I'm not going much detail, so just on a knowledge, the pump integrator we are using for the identifying or estimating the payment unevenness from the field. So the standard values also we are defined with respect to the IRC. Just you look at your free time. So these are the reasons surface may be cost inadequate, why that unevenness on the payment are happening. So with respect to that improper procedures which we are following on that field while constructing that particular road, the failure on the material, failure on the drainage facilities or the things or the equipment what we are using, the conditions of the soil, poor maintenance conditions. So all the things are reasons which behind that unevenness of payment surface which is happening on the existing or the constructed road. So these are the reasons. And the night reflecting characteristic, it is a straightforward term. And how the visibilities are there with respect to the night time, even some of the rainy time, the water surface will be there, how the reflections are happening, the foggy time, how the reflections are happening. So this good visibilities should be provided when it is coming to the widget or the flexible payment. Also, the characteristics are highly depending upon that materials what we are using. Then what will be the weather conditions of that particular site. Also the headlight. So it is varying with respect to the vehicle to vehicle, right? So the headlight reflections also one of the reasons to affect the light reflecting characteristics on the pavement. So these are the factors highly controlling the design elements of that alignment or the highway geometric design we can say. So this basic knowledge for the based on that understanding, and just moving to the first design component, which is nothing but site distance. Straightforward term. Example, you are traveling on the particular road. One assume that you are traveling in particular road. Suddenly, one object you are seeing. So it might be the tree or some tram or opposite vehicle is coming. At which point you are observing that particular object, okay, then there's a chance of make or meet accident with that particular object. To avoid that conflict, how that particular driver is reacting, he has to understand the situations, then he is deciding to applying the brake. It will avoid that particular conflict. Once he started applying, the vehicle is stopped, okay, without making any conflict. So those kind of the decisions making process as well as the reactions process to avoid the conflict, how much time or the distance he has or she has taken, that is considering as an a side distance. Okay, so hope you might be getting that explanation. So this is definitions given. Side distance is available from point is the actual distance along the road surface which a driver from a specified height above the carriageway has visibility of stationary or moving object. So example, this is an a vertical curve is traveling. So this is an eye of the driver. Okay, he's sitting, maybe the 1.2 meter is considering as a standard height, and this object is considering as an a 0.5 meter height. This is an IRC standard. At which point? So this is in a point he's first seeing that particular object. From this point to the distance the object how we are seeing, so this distance is considering as an a side distance. And when he's trying to stop, then safely if it is stopping, then that is considering as an a safe side or the stopping distance. Okay, so that is the way we are explaining. And when it is coming to the intersection, so these are the building or the trees are there. So this is on a first point we can able to observe the vehicle which is coming from the right side, and the same this is in a point, but here obstacle is that we cannot able to see, so he has to come little bit forward. At this point he is able to see this particular vehicle. So that is the things we can able to explain the side distance. And this when you're trying to propose the triangle between these two lines, so that is considering the side distance triangles. It's just an explanations it is given with respect to the junctions as well as the vertical curve. So another way, that basic definition is nothing but it is the length of the road visible ahead to the driver at any instance. It may go for that accident or may not, but at what point the visibilities are happening, so from that it is considering as a distance as a side distance. So it has a different side distance, as I mentioned that if you are able to stop safely, so that is considering as a stopping side distance or the absolute minimum side distance. When it is coming to the overtaking, so that is considering as an overtaking side distance or passing side distance. Then the safe side distance for entering the uncontrolled intersection, intermediate side distance, headlight side distance. So these are the 5 major side distance which is classified under the type of side distance. So the explanation same only given over here. The stopping side distance is nothing but at any spot you have a sufficient length to stop the vehicle, okay, at to avoid the collisions with any obstructions which you can able to observe in front of your vehicle. But you are traveling on the design speed, okay, in that design speed you are maintaining, according to that the safe stopping behavior are happening. So that distance when you are estimating and providing on the field, so that is considering as a stopping side distance, SSD. Then when you are having the minimum distance with respect to the visions of the driver when you're trying to overtaking, so that is considering as an overtaking side distance. So you are safely passing the vehicle which you are traveling along with you. So this is a vehicle traveling with you, you are traveling in a car A, so you are overtaking, so without making any conflict. This is might be the two way, but one way opposite vehicle also coming, so without making any accident with the opposite vehicle also you have to pass this particular vehicle B. So those kind of that safer distance is considering as an overtaking side distance. Then entering into the uncontrolled intersections, there is a no signalized intersection, and the driver has to observe in that intersections what are the vehicles are coming. See, he has to stop and he is observing what are the vehicles are moving on. According to that, he is crossing this particular junction. So the side distance at intersections, how it is visible, the side distance or triangle. So accordingly, we are making the passing of that particular uncontrolled intersection. So that distance is considering as a side distance at intersection. Then intermediate side distance, okay, So intermediate side distance is there. Somewhere the overtaking is not possible, right? Some road corridor and all. So in that particular corridor might be existing for the 4 kilometer, 5 kilometer, but small 30 kilometer LCV is traveling and the car is following. It is not feasible to follow that particular slowing moving vehicle by this fast moving vehicle for the 5 kilometer or the 4 kilometer. In that particular point of time, in the middle, maybe after the 2 kilometer, the 3 kilometer, we are providing the intermediate side distance. So where it is considering as a twice the stopping side distance. Accordingly, when the designs are happening, to give the provisions for that fast moving vehicle overtake the slower moving vehicle in that particular zone. So that is considering as an intermediate side distance. Then the headlight side distance, so where the distance visible to a driver during the night time. So nighttime visibilities will be there, and to avoid that nighttime visibility, what we can say, lag on that particular visibility, how that accidents are stopped. This is a side distance, the headlight. Okay, so with respect to the headlight, how long the visibility is there, how that illumination is going to avoid that accident when we are trying to observe it, and accordingly when we are studying the distance, that is considering as a headlight distance. Basically this headlight distance, where it is influencing in the sense when it is coming to the vertical curve, so upstream and the downstreams are coming, no? So in that point, that that headlight is affecting. Okay, so these are the five side distance which we are considering when it is coming to the highway design. So stopping side distance, overtaking side distance. So this is the two main side distance which we are going to deal with the problems, and that what we can say, theory as well as definitions with respect to the derivations. And remaining under, it is ultimately depending upon the overtaking, twice the overtaking, thrice the overtaking, or the twice the stopping distance, you will get the intermediate side distance. So remaining three side distance are interconnected with the overtaking and the safe side distance. So this is a brief introductions about the side distance. Now the first component, stopping side distance. So as I have explained very briefly, the stopping side distance is nothing but the minimum side distance which is available on the road at any point. The driver has a sufficient length to stop his vehicle to avoid the collisions with an opposite obstructions when he or she is traveling in the design speed. So you are traveling 100 kilometer per hour. So you are traveling in this particular road in 100 kilometer per hour. When you are reaching this particular point, if you are seeing one obstructs are there, okay, maybe the failure or the some breaks are happening in the road. Okay, when observing at this point, you are traveling in the 100 kilometer per hour, then you are approaching and applying the brake, and you can able to stop your vehicle without making any collision. So this distance is considering as a safe stopping side distance, SSD, stopping side distance, which is safely we are stopping the vehicle when you are traveling on the design speed to avoid the conflict. Basically it depends upon the features of the road height of the drivers above the road surface. IRC is assuming 1.2 meter. The driver car will be there, the seat which we are sitting from the height from the road surface to average eye height, we are considering 1.2 meter. Then the opposite objects are, we are assuming that it has a height of 0.15 meter. So in the road it is having that height of the 0.15 meter. So this is an assumptions we are having. So yes, so this is in a two criteria. This is a driver eye visibility 1.2 meter, and that height of that object we are assuming 0.15 meter. So this is the distance to make the stoppage safely. So this is with respect to the safe stopping site distance. And what are the factors are considering in the sense total reaction time of the driver? It definitely varies to the person to persons, age of the persons, gender of the person, how we are reacting in that particular situation. Then the speed of the vehicle, what is the speed of that particular vehicle, efficiency of brakes, how much efficiency the brake has, then the frictions, the previous chapter we have seen, right, the friction 0.35 longitudinal, 0.15 for the lateral. So how the frictions are happening between the road and tire, the gradient of the road. So these are the five major factors which is affecting the stopping site distance. The reaction time is nothing but how long the driver is taking to perceive that particular situation and how much time he has taken to apply the brake. So these two together we are considering as a total reaction time of the driver. So example, the previous layer, so from here he's observed that particular object. Okay, from here to here he is analyzing. Okay, if I'm going 100 km per hour, definitely I will hit it. So the decisions, perceptions, is understanding the situation till this point. Maybe this might be the 5, not 5 meter, maybe the 50 meter. Okay, so once the 50 meters is perceived, then he start applying brake from here, and from the 20 meter he is stopping his vehicle to ideal. Okay, the 0 is the speed. So the 70 meter is considering as a safe stopping site distance, SST. So this is an explanations of the total SST as well as the reaction time, how the particular driver are perceiving and applying the brake. Okay, so that can be observed. So this basically it is explained with respect to the PIV theory. Mostly you might be knowing this PIV theory, but so this PIV theory is the best way to explain that total reaction time, the incident, how the perceptions are happening. So the time required for the sensations received by the eye. From the eyes or the ears, your brain is getting the notifications or getting the sense something is going to happen. So the nervous systems and spinal cords getting the informations through the brain. So that is considering as a first actions perception. So it may take some time, some seconds. Then intellections, so where the time required for understanding the situation. So this is a dangerous situations, or it can be the manageable situations, or no need to bother it. So those kind of that understanding happening in the intellectual stage. Then the emotions, so some driver might be getting the fear, or the new or the beginner driver might be getting fear, or somebody might be getting the angry, somebody might be taking us on a cool smoothly they are acting, right? So that emotions, then it happenings, so that time also consider. Then the final one will be the final actions taken, whether you are applying the brake or not. So those decisions has been taken in the final steps. So this four part together we are explaining as an PIV theory: perceptions, intellections, emotions and volitions, and all together how much time it has been taken, that is considering as a total reactions time. So this is one of the main design parameters which we need to consider while you are estimating SSD value, safe stopping site distance. So this is the things with respect to the site distance. So next we have that what we can say a very small derivations or the explanations how the SST can be explained. Followed by we are going to cover some of the problems in this particular SST. So I will explain SST calculations. So example, so you can same we can consider. So this is an sorry, this is an existing road. Okay, so you are traveling in this particular road section. Your vehicle A to reach this particular point. So this might be the x1, and at this point you are observing your obstacles which is existing in the opposite direction. Okay, so this is in a y1. As I mentioned that it's a simple definitions. When the vehicle A touching this particular point, in this point is considering as a starting point, or the eyes observing the obstacles which is existing in y1. Okay, maybe the car or the pole are existing. From this the driver is reacting. The PIV theory we have seen, he is reacting. Okay, then he is taking the decisions and he is trying to apply the brake, and he is stopping the vehicle to avoid the collisions. So this might be taken at this particular point. From here to here he is taking the decisions. Once he taken the decisions, he is applying the brake from here to here, and he stopped this vehicle, and this distance is considering as an stopping side distance, SSD. So this distance is divided into two part. One is the lag distance, another one is the braking distance. So this might be the D1 and T2. So the SST is nothing but the summation of D1 plus D2. D1 is nothing but the lag distance, and D2 is nothing but the braking distance. So the lag distance is nothing but where he is perceiving, he is understanding, and he is trying to react it, and finally he is trying to apply the brake. So from applying the brake to vehicle getting the zero velocity, so that is considering as a braking distance. When you're adding two distance together, and the vehicle is definitely avoiding the collisions with the opposite obstacle, that distance is defined as a safe stopping side distance. Basically, the distance is depending upon the reaction time and the speed of the vehicle. Okay, so in throughout this particular unit we used to use the two parameters. One is the speed of the vehicle, which is denoted as an V. Okay, so when you are defining your speed of the vehicle kilometer per hour, the denotation is nothing but the capital V. And when you are explaining with respect to the meter per second, it is explained or the denoted with respect to the small v. So this is in the first one we are considering as a parameter in the equation. The second will be the time. So the time will be there. So time is considering as a t. It is a simple parameters which we all knows t. So other than that, some of the factors or the notations which you should know is that friction, right? I told that frictions between the surface as well as the tire. So that frictions we are denoting in the term F. Then the gravity, everybody knows the term G is gravity. So this is also sometimes we are using as an parameters in the equations. Okay. And when it is coming to the speed, okay, coming to the speed, kilometer per hour and the meter per second, the conversions are happening. Sometimes other parameters are they explained with respect to the meter or the second, okay, but the speed is given in the kilometer per hour. To make the uniformity, okay, to apply the value in the equations, all the parameters supposed to be in that same unit, right? Then only you can able to apply in that equations. In that particular point of view time, what you have to, in the sense, you have to convert that particular parameter, right? So which is existing in the kilometer per hour, you have to convert to the meter per second. So definitely you might be knowing it is a simple. So you are multiplying by 1000 and dividing by 3600. So example, so small v from the, if you want to make it from the capital V, it is in the kilometer, and when you want to convert as in a meter, you are applying by 1000. Then it is in the hour. So when you are making to make the seconds, first minute 60, for the second another 60. So 1000 divided by 3600, when you are trying to apply it, you will get the value of 0.27777 and all. So I'm just rounding up it. Then the capital V, then the meter per second. So this is the things you are getting as a final part. So okay, so from the kilometer per hour to meter per, if you want to convert it, simply you just multiply by 0.278. So example, if you have the calculator, you just try to apply. I given a 80 kilometer per hour, and I'm telling that you have to convert to the meter per second. Then what you are doing in the sense, 80 into 0.278, the value what you are achieving, so that is explaining the meter per second. So this is the conversations are happening when you are trying to convert it, and equations, the what we can say, the unit supposed to be in uniformity when it is coming to the GATE exam or the IAS exam. So the problem looks very simple, straightforward, but the trick or the hidden trick is happening with respect to the units. So sometimes kilometer per hour will be there in the hurry, so you won't get the time to solve that particular equation, and immediately you are applying without changing or converting that uh, what we can say unit, and you are getting the result, and you are making a mistake on it. So this is in a one example where the unit is playing the major role. Okay, so then another parameter, as I told, that the time. So basically the time is nothing but the reaction time in this particular SST I'm saying. So the reaction time we are assuming as per what we can say IRC, this is a 2.5 second. So the IRC is proposed the time as a 2.5 second, which we are using further in the equation. Most of the problems they won't say what we can say value for the reaction time. So keep in your mind, you just mark the value that reaction time as per the IRC standard is 2.5 second when it is coming to the stopping side distance calculation. Don't expect the value is given or missing in the problem. Okay, so the one terms they might be explaining, assume all the values as per the IRC standard. If they're explaining, you have to assume the t value was an 2.5 second. So this is the overview about the parameters, and that what we can see the notations as well as the unit and some parameters what IRC standards we have it. So here I'm concluding the today's sessions. Tomorrow we will see what is the equations for the D1 and the D2. Then we can see some of the problems. Keep ready your calculators and the pen and paper. During the class you try to solve the questions one by one. So in the today lecture, I'm just overviewing. So we have started our second unit where we have discussed about that factors which is influencing the alignment of the highway geometric design. Followed by we can see what are the elements we are going to cover in the second unit. Then we started the first element, which is nothing but side distance. Under the side distance, we have covered 5 major side distance, and we are planning to cover one by one. And the first one is nothing but stopping side distance. The brief explanations we have seen with respect to the stopping side distance. What are the factors are making a design criteria and affecting that stopping side distance, and how the definitions we are explaining with respect to the lag distance and the braking distance, including the total reaction time TID theory, how it is acting. So all the fundamentals and the basic knowledge on the stopping side distance we have covered, and there is a high chance of asking some of the questions in your competitive exam with respect to these parameters. So they might be asking stopping side distance are affected by the following parameters. They might be giving three options, and the fourth one will be the all of the above or the none of the above. For picking that particular options, you should know what are the parameters are influencing. So likewise, there is a high possibilities for asking the questions with respect to the parameters or some of the IRC standard. What is the reaction time? What is the longitudinal frictions value or the lateral frictions value? So these kind of the standard questions we can expect for your competitive exam. So with that, I'm concluding the today's session. So tomorrow we will see that small derivations and the problems related to the stopping side distance. Any doubt from the today's session, student? So I allowed the mic. If you have any doubt, just let me know. Else you post the questions in the chat box. Okay, if there is a no doubt, so tomorrow we will meet. Thank you, everyone.
Thank you, sir.
Thank you, sir.